Hello guys, and welcome back to another video. Now in this one we're taking a look at equations of tangents, and this is going to be equations of tangents to curves and equation of tangents to circles. We're going to see two very different examples. So one is a circle, one is a curve. One requires calculus, one does not. So suitable for GCSE and AS level, I guess. Now just quickly I want to say, if you are new around here, then make sure to hit that subscribe button. A lot of the people watching my videos are not subscribed currently, so make sure you hit that red button. Okay, so let's look at our first example. A circle C has equation x squared plus y squared minus 10y equals 0. Find the equation of the tangent to C at the point A, which equals 4, 8. So x equals 4, y equals 8. Now the first thing I like to do with these is somehow draw a picture and sort of visualize what's going on. And the way we're going to do that is get the equation of the circle in what's called the completed square form, or in a way that allows us to quickly identify the radius and center of the circle. So we do this by completing the square, as I've just sort of gave away, and we complete the square on the x terms and the y terms. Now there's no other x terms other than x squared, so we can just leave that as it is. With the y squared, we're going to get y minus 5 all squared minus 25, and this is still equal to 0. So rearranging slightly, we just get x squared plus y minus 5 squared equals 25. Now if you're familiar with the equation of a circle in this form, it looks something like this. X minus a squared plus y minus b squared equals r squared. And this is where AB is the center and r is the radius. Okay, so we've gone from our x squared plus y squared minus 10y equals 0 to this. X squared plus y minus 5 squared equals 25. So hopefully you can see that this tells us that the center is 0, 5, and the radius is 5. Right, so now we can draw a little picture. Okay, so here's our little picture. We've got a circle centered at 0, 5, and its radius is 5. So in other words, the distance from the center to the edge of the circle, any point on the edge, is 5. Okay, we know that the point A equals 4, 8 is a point on our circle, so let's put it on. Perhaps it's somewhere around here. So I'll write this in as A 4, 8, and we want to find the equation of the tangent, which looks something like this. Okay, so we want to find the equation of this curve. Let's call it T. So we know a point on the line. What we don't know is its gradient. However, we can find the gradient of this line here. Excellent. So what we can do is find the gradient of this radius here. So gradient of the radius. And hopefully you can see why this is going to be helpful, because the radius and tangents are always perpendicular. So the gradient of the radius, well, that's just the difference in y's divided by the difference in x's. So this is 8 minus 5 divided by 4 minus 0. So this is 3/4. So this implies the gradient of the tangent, the one we're looking for, the gradient of t, equals minus 4/3. And if you're unsure of why that's true, then check out one of my most recent videos. It's called Why Do Perpendicular Gradients Multiply to -1? So we're almost there. Now we've just got to use the formula y minus y1 equals mx minus x1. So we know a point on our line, that's A, which equals 4, 8, and we know the gradient now, it's minus 4/3. So we get y minus 8 equals minus 4/3 x minus 4. Now be careful with your negatives, but hopefully cleaning this up you should get, well, 3y minus 24 equals minus 4x plus 16, and so we're going to get 4x plus 3y minus 40 equals 0. And that is indeed our final answer, the equation of the tangent to the circle at the point A equals 4, 8. Okay, brilliant. So now we're on to example 2, and this will require some calculus. So if you haven't seen any calculus, then there's a fantastic playlist by 3 Blue 1 Brown, which I will link in the description if I remember. And also I plan to do an introductory calculus playlist at some point. Also, someone did request this video a while ago, and I'm sorry it's taken me a while to get around to doing it, but here it is. So let's draw a little picture of what the curve y equals x cubed looked like. Now, for GCSE level math, you should know what this looks like. So it's not quite a quadratic, it's actually got 3 distinct points. So cuts through 0 like that and then goes back up. And again, bear with me with my drawings. And of course the point 2, 8 is going to be somewhere around here, let's say. So this is 2, this is 8. Again, my picture isn't drawn to scale the best. And the tangent to the curve at this point is going to look something like this. Okay, so we need to find the gradient of the tangent. And this is exactly what calculus was invented for. So calculus is all about, well, certainly differential calculus. Take a curve, we differentiate it, this gives us the so-called gradient function. Okay, and the main rule for simple equations with powers like this is that when we differentiate, we write dy by dx. We take the power, 3, we multiply it at the front, so we get 3x, and we subtract 1 from the power. So this is our gradient function. And what does the gradient function do? Well, it's a very special function, and it allows us to find the gradient of this curve y equals x cubed at any point that's on the curve, which is just fantastic. And it uses some limits and some and some infinitesimally small numbers, and again, that will be coming soon. So let's find the gradient at the point 2, 8. Well, when x equals 2, that's our gradient point. Dy by dx, then, our gradient is going to be 3 times 2 squared. So this is just 12. Okay, so therefore, the gradient of the tangent at our point at A is 12. So we found our gradient of tangent. We don't need to do anything with the perpendicular lines because that's fine. And now we can just do this exact same process. Using our point, we can use the y minus y1 equals mx minus x1. So let's do that. And our point is 2, 8 this time. So we get y minus 8 equals 12x minus 2. And I'll leave it in terms of y equals. So this tells us that y equals, well, 12x. 12 times minus 2 is minus 24. Add 8 is minus 16. And that is the equation of the tangent to the curve y equals x cubed at the point 2, 8. So I really hope you found this video useful. Hopefully it's given you a bit of an insight into why calculus is so great. So with the circle, we could easily find the equation of the tangent. With curves such as x cubed, x squared, and so on, and even more complicated, we're going to need calculus to help us. Thank you very much for watching. If you've made it this far, please leave a like. It really does help me out. See you next time. Bye bye.